Okay, this is the last video for the base case function IEEE 33 bus, and the same thing for the IEEE 90 bus. But the difference between 69 buses, it is the number of buses difference, and but the same methodologies and the same thing for the code. We will go to the that code is quickly. The last function is function one. It is the reliability function, and dependent on the number of customers and the number of residential customer, commercial and industrial customers, we calculated the average consumption, and then the network, as you see here. The network, the PV went, it is 0, 0 in the base case, and the network rated function. And after that, we also read it, the load and the capacity factor of the PV and wind, and how to calculate the PV and wind. This is the wind. This is the wind. The wind hourly generation. And after that, we try to calculate it simply the expected energy not supplied. The expected energy is not supplied. It is the whole generation. This is the whole generation summit and minus from the load. And after that, we calculate. We divide it on the number of hours for the whole years. And the same thing for the loss of load. After we calculated not expected energy not supplied, we also calculated the percentage of losses. The percentage of not energy not supplied is the loss of load expectation. And after that, we also calculated the system average interruption during the index, duration index. So we also dependent on that energy not supplied. This is that mean what is the average of interruption of the load during the years. The system, I mean that the whole system, but calculated also a customer average interruption duration index. It is dependent on the number of customers. As you see here, we have the number of customers for each type of load, and then this is the output will be go to the base case, as you see here, to print it here. We will run from here, as you see here. After we run that, the program will start to make a load of load reliability function, and after that we print the result. And during to wait the program to print the result, we will explain about the IEEE 3096. The same thing for the base case, but the difference is the number of buses. But all the methodology is the same, all the function is the same. The program will print the result now. As you see here, from the base case, it is the power loss 34%, and for the reactive power 23%, and the voltage deviation as 0.72, and the voltage stability index. This is mean that for average. I mean this is average of years. And the same thing, but this is the accumulated for whole years. As you see here, expected not supplied because the rated because this is exceed the rate of network, and the percentage of that energy not supplied, and the system average duration about 2,000 for 400 for 2,044 hours per year, and the customer average interruption duration index about the average. This is the average interruption for 12 customers. This is for base case. When we go back to the IEEE base case, the same thing, the same function, but the difference is the load bus for 2069 and the line for 69. This is the difference. But the other thing is the same. As you see here, PV capacity, but also the network rate is different also here. And then The same thing for all the functions. To calculate it, as you see here, we calculated the number of customers and the energy not supplied and the customer average, and the same thing for the load flow, but is the different. It is only the system, but the methodology is the same. So this is for the base case system. We hope it is clear for you. And thank you for your waiting, and sorry for late about to send a video. Thank you very much.